The last group of angles that we are going to look at are the angles that are multiples of pi over 6. Okay, so this is going to be constructed in the same way that we made the angles that were multiples of pi over 3 and the angles that are multiples of pi over 4. It's going to be done in the same way. Okay, so I'm going to start. I have my unit circle. I'm going to put the vertex at the origin. Okay, I'm going to go ahead and put the initial side down for any angle on the unit circle. Okay, so my initial side will coincide with the positive x-axis. Okay, we will rotate counterclockwise, but remember this is our starting position. We can consider this to be 0 degrees or 0 radians. Okay, so again, we know that there are pi radians in the top half of the circle. So since we're dealing with multiples of pi over 6, we need to break the top half of the circle up into 6 equal parts. Okay, so I am going to pause the video. Okay, I'm going to break the top half of the circle into 6 equal parts and color code those sectors, and then I will resume the video. All right, I'm back. I have broken the top part of the circle, which we know is a full pi radians. I have broken the top half into 6 equal parts. So you can think of each of these segments as representing pi over 6 radians individually. Okay. All right, so now we will start rotating counterclockwise to mark off our angles. Okay. So again, we've got every single angle will have a vertex at the origin. The initial side for each angle will coincide with the positive x-axis. So here is our starting side, and then we will rotate counterclockwise to get our terminal side. Okay, so here's our first rotation. We are going to rotate this direction pi over 6 radians. So this angle is going to be pi over 6. Okay, and then for the next angle, okay, we are going to start with our initial side and we are going to rotate 1 pi over 6, 2 pi over 6 to reach this particular terminal side. So this angle is going to be 2 pi over 6. Okay, this reduces to be pi over 3. Okay, and then we go again. Okay, so back to your initial side, we're going to rotate 1 pi over 6, 2 pi over 6, 3 pi over 6 to get this terminal side. So this angle is going to be 3 pi over 6, which reduces to be pi over 2. Okay, let's keep going. All right, back to my initial side, I'm going to rotate 1 pi over 6, 2 pi over 6, 3 pi over 6, and end up here at 4 pi over 6. Okay, so 4 pi over 6, that is going to simplify to be 2 pi over 3. Okay, let's keep going. Next angle, back to start your initial side. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Okay, so this angle right here with this terminal side is going to be 5 pi over 6. Okay, and then one more rotation to get to the full half circle. Okay, so back to our initial side. We are going to rotate pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then right here brings us to an angle of 6 pi over 6, which reduces to pi, which makes sense because we know there are pi radians in half a revolution. Okay, so we've gotten our angles from the top side, top part of the circle. Okay, we're going to do the same thing to the bottom part of the circle. The bottom half of the circle is pi radians in itself, so we can break it into 6 equal pieces. So I am going to pause the video. I'm going to break the bottom half of the circle into 6 equal pieces and color code the sectors, and then we will draw out the remaining angles that are multiples of pi over 6. I'm back. All right, so I've got the bottom half of the circle and I broke it up into 6 equal parts. So just like the top half of the circle, you can consider each of these sectors to be an angle of pi over 6 in its individually on its own, okay? So we are going to continue rotating. We've already looked at the angles of 0 radians, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi, and we will continue. Okay, so back to our initial side, which coincides with the positive x-axis, we are going to rotate 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and now we reach this terminal side, which is going to be 7 pi over 6. Okay, so there's that angle. Okay, and we just continue until we complete the circle. Okay, so next will be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, and then we get here. This is going to be 8 pi over 6. Okay, and that is going to reduce. Both of these numbers are divisible by 2, so this will reduce to an angle of 4 pi over 3 radians. Okay, all right, continuing on, just a couple more of these. So the next angle, let's see, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 pi over 6. Okay, that will also simplify. Both of these numbers are divisible by 3. So this is going to be an angle of 3 pi over 2. Okay, and next angle. Okay, we're running out of room here. There's so much rotation going on. That's why we won't break it up any further after multiples of 6. All right, so we've got next angle, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, and then terminal sides right here, this is going to be 10 pi over 6. Okay, this reduces, both of these numbers are divisible by 2. This is going to be 5 pi over 3. Okay, couple more angles, hang tight, we're almost there. All right, next rotation. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6. And then we reach right here, terminal angle, this is going to be 11 pi over 6. Okay, that does not reduce. Okay, and then last angle, yay. Okay, we do a full rotation around the circle. Okay, so if we trace this out, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6. Okay, and we reach the initial side again. Okay, so this angle is going to be 12 pi over 6. That reduces to be 2 pi radians, which we already know 2 pi radians is coterminal with 0 degrees / 0 radians. Okay, one full circle should be 2 pi radians like we expect. Okay, so here are all of the angles that are multiples of pi over 6 on our unit circle. Okay, there's a lot of them because you can see if you take your top half of the circle and you break it, the more pieces you break it up into, the more angles it generates. Okay, now one thing you should notice, a lot of these angles we've seen before. Okay, so for example, pi over 3, 2 pi over 3, 4 pi over 3 down here, and 5 pi over 3, we actually got those when we looked at the multiples of pi over 3. Okay, so those angles are both multiples of pi over 3 and multiples of pi over 6. Okay, so just keep that in mind. So sometimes, you know, some of these angles fall into more than one category. Okay, another example would be pi over 2. Okay, pi over 2, it's a multiple of pi over 6. It is also, if you go back to multiples of pi over 4, okay, we've seen pi over 2 before, okay? So again, they can fall into more than one category, okay? We can go ahead and convert these over to degree measure, okay? So if we do that, let's go ahead and do our conversion factor. So if you have pi over 6 radians, let's change that over to degrees by multiplying by 180 degrees over pi radians. The radians will cancel, the pi's will cancel. This will give us 180 degrees divided by 6. That's going to be 30 degrees, okay? So every time you see a sector on this circle, the angle individually measures pi over 6 radians or equivalently 30 degrees, okay? So you can convert each one of these to degrees by doing the conversion factor, or you can just rotate through and every time you pick up a sector, you add 30 degrees, okay? So we've got 0 degrees, 30 degrees, go on to the next angle, pi over 3. Pi over 3, to get that angle in degrees, you're just going to take 30 degrees and add another 30 degrees. So pi over 3 is 60 degrees. okay? And then we rotate to the next angle, add another 30 degrees, so we know that pi over 2 is 90 degrees, which we've seen before, and we've seen this right angle, okay, so that makes sense. All right, 2 pi over 3, okay, what is that equivalent to? We're just going to tack on another 30 degrees, so 90 plus 30 is 120 degrees, okay? Move on to 5 pi over 6, 120 degrees plus another 30 degrees, that's going to give you 150 degrees, okay? Moving on, pi radians, that measure, okay, to convert that to degrees, okay, we just need to take the previous angle and add 30 degrees, okay, so 150 plus 30, that's 180 degrees, okay, we know that makes sense because at that point we've reached the half circle mark, so it should be 180 degrees, okay. So now 7 pi over 6, this angle, okay, to get its measure in degrees, okay, we're going to do 180 and we're going to add another 30 degrees to it, so this is going to be 210 degrees. Okay, keep moving. Okay, to move over to 4 pi over 3, we're going to tack on another 30 degrees. So 210 plus 30 is going to be 240 degrees. Okay, and as we keep rotating, now we reach 3 pi over 2. Okay, so that in degrees. Add 30 degrees to 240. So this is going to be 270 degrees. Okay, and then we are to 5 pi over 3 if we rotate again. Okay, so to get this in degrees, we're going to do 270 plus 30. That brings us to 300 degrees. Okay, so keep going. You can see what we're doing. We're just tacking on 30 degrees every time we rotate. Okay, so that means 11 pi over 6 is going to be equivalent to 330 degrees. Okay, and then last one, your last rotation will bring you back to the initial side. So you would have gone one full circle. Okay, so to get this measure in degrees, you're going to take 330, add 30 degrees. That gives you 360 degrees as expected. Okay, so here are all the measures in both radians and degrees.